Hello, welcome to this video. Today we're going to do 10 proportional reasoning word problems from the SAT practice website. These are also the word problems that will be on the assessment within the first unit of this quarter. So let's get started. I'm going to copy the first question. Right. So it says here, in 3 seconds, Kevin can dribble a basketball 13 times. If Kevin dribbles at this same rate for 27 seconds, how many times will he dribble the basketball? So we are comparing two things here. We are comparing dribbles to seconds. And our initial ratio is 13 dribbles in 3 seconds. They want to know how many dribbles in 27 seconds. So we set up our proportion. We're going to cross multiply where we have two numbers, 27 times 13. 27 times 13 is going to give us 351. And then we divide by the number that we didn't use. We didn't use 3. 351 divided by 3 is 117. Good. Let's try the next question. Okay, our second question. I think some of the classes did this one in class, but regardless, that's on the record. So in this question, it says the ratio of the amount of vitamin A in cow milk to the amount of vitamin A in goat milk is 3:4. If a liter of cow milk has 1,560 units of vitamin A, how many units of vitamin A are in goat milk? So we are comparing cow milk to goat milk. And we can see that the initial ratio, again, order matters. So cow milk is listed first, goat milk is second, and then 3 is first, and 4 is second. So it's 3:4. My second ratio here, they give us an additional piece of information. A liter of cow milk is 1,560. Cow milk is in the top, so that's where we'll put it. Again, we're going to cross multiply where we have two numbers. We have two numbers here, 1,560 times 4, and that's going to give us 6,240. We're going to divide by the number we didn't use. We didn't use 3. 3 into 6 goes twice. 3 into 2, no. 3 into 24 goes 8. So we're looking at 2,080. 2,080 units of vitamin A in goat milk. 2080. Good. Let's take a look at question number 3. Hey, this question says, the National Research Council recommends keeping 1:3 copper to zinc ratio in a horse's diet. If the horse is getting 420 milligrams of zinc per day, how many milligrams of copper does the council recommend the horse should have? So again, we have a copper to zinc ratio. And initially, it's 1:3, 1 copper to 3 zinc. It then goes on to say that there's 420 milligrams of zinc in the horse's diet. We're going to cross multiply where we can. equals 420. Dividing by the number we didn't use is 3. 420 divided by 3 is going to give us 140. So there's 140, and that is, I guess, milligrams of copper. Okay, question number 4. The rate of perceived exertion, RPE, scale runs from 0 to 20 and is approximately proportional to a person's heart rate. If the RPE rank of 20 corresponds to a person's maximum heart rate of 205 beats per minute, what RPE rank corresponds with the person's resting heart rate of 70 BPM? Round to the nearest integer. So sometimes you'll hear me say that the SAT uses some weird things, and RPE, I guess, could be considered a weird thing. But as long as you understand that it's a proportional relationship, it really doesn't matter if you understand what RPE is all, or even heart rate or beats per minute. They're just things. They're categories that we're measuring in a word problem. So I can see that we have a ratio of RPE to I guess BPM or heart rate. Well, maybe heart rate's easier to understand. Okay. And on this heart rate, they give us an initial ratio of 20 to 205. So an RPE of 20 is proportional, equates to a 205 BPM. From that, they want to know what an RPE would be for 70. All right, so 70 is a BPM, so we'll make sure to put it at the heart rate. 70 times 20 is going to be 1,400. Divide by the number we didn't use, 205. And we get, it doesn't go in equally, but it's about 6.8. So I noticed here that we want to round to the nearest integer. So I'm going to say that our answer is going to be 7 here if we round to the nearest integer. Put that in for an answer. Good. Next question. All right, so here we have a certain movie theater has a ratio of length to width of a movie screen is 16 to 9. If the length of a screen is 90 feet, then to the nearest foot, how many feet is the width? So we're dealing with a length and width problem here. And they're saying the initial ratio is 16 length and 9. And again, order matters, length to width. So 16 to 9. And they want to know, well, what happens when the length is 90? Length is in the top. We'll put that up here. This in the bottom. We're going to cross multiply where we can. 90 times 9 is going to give me 810. And from 810, I'm going to divide by 16. Dividing by 16 here is going to give me 550.6. So about 50.6 gives me that 810 divided by 16. Round to the nearest foot. So we know it's going to be A, 51 feet. All right. So that was the first 5. We're going to do 5 more. So let's go down to that practice again. This practice is on Khan Academy. It's the official College Board practice site. This is a video on ratios, rates, and proportions. Okay. All right, start this one off. Leave some room down there. All right, so here we got miles traveled and gallons of fuel used. If we have a table, gallons used over miles. Mark looks like he used 13 gallons on 286 miles. Daniel used 11 gallons, but we don't know the number of miles. It says here the table above shows the number of gallons of fuel used by two drivers, Mark and Daniel, during two different car trips on the same highway. If the two drivers have the same model cars that get the same miles per gallon on the highway, then to the nearest mile, how many miles was Daniel's trip? So we actually, they set it up for us so that we have a proportion. And believe it or not, the proportion is actually very visible in the table here. So if we were to look here, we have gallons, right? We're comparing gallons to miles. And they've kind of set the initial ratio right here. It's 13 gallons to 286 miles. Now from here, they gave us 11 gallons is how many. So they actually did a lot of the work for us. So 11 times 286 is going to give us 3146. We divide by the number we didn't use, so we're going to divide by 13. When we divide by 13 there, we're going to get 242. So it's 242 miles. All right, in this problem, it says in a small U.S. city, the ratio of people to cars is approximately 1.85 to 1. If 12,100 people live in the city, to the nearest 100 cars, approximately how many cars are in the city? So the ratio is very clear here. We have people to cars, and they gave us a ratio of 1.85 people to one car, and then they tell us there is 12,100 people. They want to know how many cars to the nearest 100th car. So cross multiplication here is going to give us 12,100, and then we take 12,100 and we divide by 1.85. It's going to give us approximately about 6,540. Nearest 100 will give us 6,500 cars. So there's approximately 6,500 cars in that city. Question. When David arrived in the country of Georgia, he exchanged 165 US dollars currency for 385 Georgian laris. When he was ready to return to the US, he had 147 laris left. Assuming the exchange rate is the same, how many US dollars is that worth? So the ratio here is going to be US dollars to laris. I think I'm saying that right. And his initial exchange was $165, gave him 385 laris. So the exchange rate is going to stay the same, and he has 147 laris. That's going to go in the bottom. Okay, we're going to cross multiply where we have two numbers. 165 times 147, 24,255. We're going to divide by the number we didn't use. 24,255 divided by 385 is going to give us 63, and that's dollars. $63 in exchange. Okay. All right, in this question we have, in one country residents were asked to name their primary language. The ratio of residents who said French to those who said Punjabi was 110 to 7. If there are 7,260,000 residents who said French, about how many thousands of residents said Punjabi? So we are comparing French residents to Punjabi, and we have an initial ratio of 110 French and 7. They then give us a big number, and they said that the 7,260,000 that said French, so that's going to be up here. On the assessment in class, there'll be smaller numbers. I know we're not going to be allowing calculators on that first test, so there'll be smaller numbers. You won't have to deal with that. But if we do 7,260,000 times 7, because it's a single digit, we can work it out. It's about 820. 50,820,000. And then we divide by the number we didn't use, so we're going to divide by 110. A lot of big numbers going on here. That's going to go in about 462,000. So 462,000 is the number of Punjabi residents. They said about how many thousands. So notice they underlined thousands here. So they want you to just give the answer in thousands. So we will give the answer of 462, and that will give us the correct answer. All right, last question. I'm going to reload the page. Last question here. Let's copy this. All right, our final question says, the force that friction exerts on a car is proportional to its mass. Suppose friction exerts 6,272 newtons of force on a 1,600 kilogram car on a wet road. How many newtons of force would friction exert on a 2,400 kilogram car under the same conditions? So our initial ratio is going to be force to mass. And initially they said that 6,272 newtons of force are exerted on a 1,600 kilogram car. They go on to say that the car weighs 2,400, so the mass would be the proportional part. We are working with more big numbers, so perhaps, I'm not sure if this is a calculator question. We can check to see if it is. But 6,272 times 2,400 is like 15 million. 52. 800. And then we divide by 1600, and we get approximately 9,408. So we found the amount of force, 9,408. All right. So that right there is 10 SAT questions from the College Board practice website on Khan Academy. Let me know if you have any questions. On the test, there will be similar questions to these, so make sure you're ready.